So today we're going to be doing the Chemistry Week 9 AMS quiz. It's really easy this week. Part of it's organic chemistry, but really easy. Anyways, let's start. Hydrocarbons are organic compounds. Which of the following atoms are only present in hydrocarbons? I think it's obvious kind of from the name. Hydrocarbon. Hydrogen and carbon. So that, I don't really think I need to explain it because it's kind of in the name. Hydrocarbons are made out of only hydrogen and carbon. Moving on. Which of the following is true about graphite, diamond, and fullerene? When they say fullerene, they mean Buckminster fullerene. It's in the notes for carbon. So they all have the same chemical composition because they're all made out of one thing, carbon. Which brings us to our point. They're all made of carbon atoms only, and they're allotropes because allotropes, what are allotropes? They are each of two or more different physical forms which an element can exist. That's what allotropes are. So that is why we say that all these three are allotropes, because they're all made out of carbon, just rearranged in different thing in a different way that makes them have a different function. They're all good electrical conductors. This is wrong because it's only graphite that's a good electrical conductor. They all have the same physical properties. No. The fact that only graphite's an electrical conductor makes it so that they don't have the same physical properties. And if they all had the same physical properties, then diamond would be as slippery as graphite. And that graphite would be as hard as diamond. But they're not. That's why they don't have the same physical properties. Now moving on. Now from here, they say, which of the following are organic compounds? Whenever you see the word organic compound, it means one thing. Anything that has C. Well, anything that has C and H. They are all organic compounds. CHCl. This does not have, it has H but not C. CH4, CH12O6 but not CO2. Because CO2 is a gas and it's not really a compound. It is a compound but it's not an organic one. Now, moving on. Which of the following are alkanes? Now, a little background information about alkanes. Alkanes are one of the families of organic chemistry, and they're the one that have the form CnH2n+2. This is the formula for an alkane. Whenever we want to find an alkane, we use to find this. So C is 1. So 1, and then H, 2 times 1 is 2, plus 2 is 4. So CH4 is an alkane. 5 times 2 is 10. 10 plus 2 is 12. C6H6. This isn't an alkane because you have the same number of carbons as hydrogen. So this is not correct. Now C3H8. C3H. H time is 3 times 2 would be 6. 6 plus 2 is 8. So this is also C2H4 is a different thing. C2H4 is an alkene. Alkenes have a different formula of CnH2n, but that's it. This is an alkene. This, we're gonna use it for other questions, but so far, this is for alkanes only. Now, moving on. How are alkenes produced? So alkenes can be produced by dehydration reaction of alcohols and by the cracking of long chains of alkanes. Combustion, not really. Substitution, not really. But we know for sure when you crack an alkane or when you dehydrate an alcohol, it gives you an alkene. These, I prefer you memorize it. And this is for alkanes. This is what I told you about, CnH2 and plus 2. Now, if it has 2 carbons, so Cn is 2. H, so 2 into 2 plus 2. So C2H, 2 times 2 is 4. 4 plus 2 is 6. C2H6. Now, sorry, I didn't realize I skipped the question. Alkenes. I told you already that alkenes have this form. CnH2n. These are full on memorizing. You have to memorize for alkenes and alkanes for tomorrow's exam only though. And anyways, given the molecular formula of an alkene having 2 carbons, so it's CnH2n, right? So C, 2 carbons, so N is 2. H, 2 times 2 is 4, and that's it. Now, moving on. This question is about isomers. So what are isomers? Isomers are compounds that have the same number of carbons, so see 1, 2, 3, 4 and 1, 2, 3, 4, yet they are shaped in a different form. And how do we identify an isomer? You use the line test. It is when you draw a straight line, can you get all the carbons in one line? Here we can get all the carbons in one line and it would be correct. Or not correct, all of them are correct isomers. They're the same compound, but they're built differently, يعني. When you come to but for isomers of this compound, because this is the straight one, this is the one that has no bends, no branches, no nothing. Let's say this is the base one. When you want to build up on it, or you want to you want to add branches to it, if you can do if when drawing you have to draw one straight line. If you can get all the carbons in one straight line, it's not really an isomer, it's the same thing. It would be the same exact one. I'll show you what I mean in a different question, but for this question, we know they're isomers because no matter what you do, you cannot get all carbons in one straight line. But that's not really what they're asking for in this question, but that's extra information we need to know. Now, what do compounds 1 and 2, which are both isomers, have in common? Molecular formula. They all have the same number of C atoms and H atoms. Now, we call these two, I've been saying it the entire question, isomers. When they have the same number of carbon, yet they're built in different ways, on different branches. Okay, carbon dioxide, we know already, turns a clear solution of lime water milky. Honestly, we should know this by now. We've done experiments like a million times. Now, carbon dioxide is slightly soluble in water. Again, this is something that's been mentioned as memorization. We can't really understand it. It's something to do with the bonds, but all we need to know is it's soluble in water. Carbon dioxide is responsible for the fizzing action of soft drinks. Whenever you see this fizzy part on the top of your drink that takes up like 50% of your drink in the cup, this is usually carbon dioxide bubbles that are waiting to pop so you can, they can go. So this is what's responsible for the fizzing action in your cola or your Sprite or whatever. Next question. Okay, so let's read. The dilute acid. So we have an acid added to an unknown sample and it turns clear lime water milky. If it's an acid being added and clear lime water is milky, the only thing you could add it to is carbonate, because we said clear lime water turns milky with CO2. The only thing that can produce CO2 is a carbonate. Okay, so we have the following compounds: CH4, C2H6, and C3H8. Let's imagine we do not know that these are alkanes, but they're telling us they have the same general molecular formula, they can undergo substitution, and they have similar methods of preparation. What does this mean? They're members of the homologous series. What does this mean? They are all the same family of organic chemistry. That is it for this question. That's what homologous series means. Now, let's move on. Which of the following is a hydrocarbon? In this list, they gave you a lot of options with C and H, but they gave you OH and some things with H. For a hydrocarbon, it only has C and H. Only. Now, here, this question is memory with understanding. Whenever they tell you unsaturated, it means it is an alkene. Alkene. And we said alkenes have a general formula of CnH2n. So C6 times 2, 12. So this is an alkene. And C2H4 is also double the number of hydrogens than carbon. So it's also unsaturated. What does unsaturated mean? Unsaturated means has a double, I'm just going to write that, bond. Has a double bond. But whenever they tell you saturated hydrocarbon, it means it's an alkane. So CnH2n plus 2. But it means it only has single bonds. And our alkanes in this example are 512 and 38. HC3H8. Now that's it for this question. Now let's move on to the next. Okay. Now when upon adding compound X, the reddish brown color of bromine changes, is rapidly discharged. Now whenever you see bromine, it means it undergoes bromination. The thing that undergoes bromination is alkenes. They undergo bromination. And either way, if let's say you went into the exam not understanding anything, you never saw this chapter in your life, all the options were options of alkanes. Like if you noticed, they were all, this is the only one where the H has double the amount of 2. This was the only alkene. All the other options were alkanes. So by logic, pick the odd one out if all of them are alkanes and you have one alkene in this question. Because upon a compound X, we don't really know anything about this compound. But anyways, whenever you see bromination, know it's alkenes. Now next question. Now this is what I'm telling you about structural isomers. Whenever you see the word structural isomer, it means you have the same number of carbons, but they're branched. They're not all on the same line. This is what a structural isomer means. Now here, they're all in one line. You're going to say, okay, but all of them have changed positions. They all have branches. Yes, but let's look at the two examples that aren't highlighted. This, one line, this, one line, and you get them all. This, one line, you'd have this left out. Let's try in a different way. This, okay, you still have these two left out. Okay, let's try. You still have this one left out. No matter what you do, you cannot draw one straight line where you get all of them in that line. So that is what makes it a structural isomer. Here, you can either do like this, or like this, or like this, or like this, or like this. But either way, you're gonna have two left out at a time. So this also is a structural isomer. Whenever thinking about it, think about it like it's a human. When you're asleep, you're laying flat. This is, let's say, when you're sitting up. And this is when you're slanting. But either way, when you sit in a different position, you don't change as a person. But when you move something, you do change. Now, let's move on. It's not changing the question. Wait. Anyways, yeah, it took a long time to load. Okay, so Cl2 chlorine is added to methane. Cl2 added to CH4. The reaction between methane and chlorine can be sped up by UV light. We have to memorize this because it is one of the factors, or like an enzyme, but not really. And it's sped up by UV light. So it's a photochemical reaction, so it needs sunlight to proceed. The reaction is called a substitution reaction because when you add chlorine to a alkane, you're replacing this in place of something else. We're gonna see what I mean now. So it's substitution because chlorine takes place of a hydrogen atom in methane. Now, whenever you have them substituting, you're always gonna have, and whenever it's like, you're always gonna have an H and the Cl. But if it's like, this is the only way, listen, this is the only product where you're not allowed to have a C in it, because this is just a single bond between H and Cl. This isn't really an organic compound. It's just a CH and bond, HCl. This is what it is. But whenever you want to like actually have a bonding, you have to have a C in the middle, surrounded by either some H's, some Cl's, or you can have here, and you have one H, 3 Cl's. Here you have 2 H's, 2 Cl's. Here you have no H, 4 Cl's. So these are all probable. Why? Because whenever we have a substitution reaction, it's like you're replacing the H. Like here you had before 4 H's, but we put Cl2 with it. So depending on how much Cl2 you put, you're removing 3 carbons, replacing them by Cl's. These were all hydrogens. But here you wanted to add 2 Cl's. Here you had 4 hydrogens, you wanted to remove them all to make them CCl4. You can. And this is just a HCl bond, like I said. And here we don't choose it because we have no C nor no, what's it called, Cl. We don't have Cl either way. Here we have Cl and H around it. This is wrong because we're changing from H to Cl. So we can't have no carbons or 4 H's and 1 Cl. Now, here we have an ethene molecule, which is an alkene. So what's the type of reaction when you react it with hydrogen gas at high temperatures and pressure? It is an addition reaction because you're adding hydrogen gas to it. Even you could call it hydrogenation, but hydrogenation either way is a type of addition reaction. Now the chemical formula for hydrogenation, which means when you're adding H2, so it was CH4 and you added 2 more H's to it. So what does it become? C2H4 plus 2 H's. It becomes C2H6. Whenever you add hydrogen to an alkene, it becomes an alkane because hydrogen is an H2. So whatever you do, you're adding the 2 because look, CnH2n is your ethene. CnH2n plus 2 is your ethane. So when you add, or like your alkene and your alkane, whenever you add 2 to an alkene, what's the difference between the alkene and the alkane? Nothing. So they both become alkanes. Now, when you add, didn't we say alkenes are unsaturated because they have a double bond? Okay, when you add hydrogen, it becomes saturated because now you have an alkane, right? So it becomes a saturated hydrocarbon. You're gonna ask, oh, but how's it saturated? What happened to the double bond? Now I'll explain. When you want to convert ethanol to, when you want to convert ethene to ethanol, we have to steam it, which means like put steam with it, and you add the ol, which is C25OH, which means you added 1 more H to the C2H4 and an OH, which means H2O. That's practically it. You could like literally find it out by looking at the 2 formulas. Now, ethene readily reacts with chlorine at room temperature. Locate the products of the reaction between ethene and chlorine. Now we know ethene has a double bond. But what happens when we react it with chlorine? Or it will break that double bond. When you break the double bond, it turns into 2 single bonds. Those 2 single bonds are gonna, because look, let's go back to the part where we said it's a addition reaction, or when you break it, what does it become? It becomes an alkane. Didn't we say that? When you add hydrogen to it? When you break it, it's like you're making a double bond. When you break it, it's like you're making two new, like it's equal, a double bond is equal to two single bonds, right? So when you're making two single bonds, what's gonna come to them? What's gonna connect to the single bonds? Hydrogen. But here you're adding Cl2. We already said in a previous question, when you add Cl2 to an alkane, the Cl's are gonna replace the hydrogens. So here we had hydrogens to make the alkane, but when Cl2 came, it replaced two of them, leaving us with 2 Cl. Here this is correct, but we have only 1 Cl and we added Cl2. Here this is wrong because we still have a double bond. Here this is wrong because whenever you break the double bond, it has to be on the edge pieces. You can't have your Cl in the middle pieces. It has to be on the edge. This is another important fact to keep in mind. Whenever you break it, whatever is not part of the original alkene, because an alkene, it's shaped like H. Whatever is not part of this, when you break it, you have two new bonds. So 1, 2, right? So H and H. But now we're replacing them with Cl and Cl because you have Cl2. So this, it has to be on the edges. Keep that in mind. Now, moving on. Which of the following is unsaturated hydrocarbons? When we say unsaturated, we mean there is presence of double bonds. Whatever has a double bond, select. Whatever does not have a double bond is saturated. This pretty much is memorization or just pure reason. We know diamond is very strong because you can cut glass with it. And it's real lustrous, so we make jewelry out of it. Graphite, we know already from chapter 4 that it's it's conductive, but it's inert, so it makes electrodes. And we know that it's graphite in the pencils because it's slippery, and we know it's used for furnace linings because it can withstand heat or something. It's all of this is in the chapter 4 notes. Now, when you have an amount of oxygen that is limited, carbon burns. Now we know carbon burns with oxygen. C2 burns with O2. But they're telling you amount of oxygen is limited, so you have O. So you have C2O. So carbon and monoxide, one oxide. Memorize it, but also understand it. Now, the above reaction is a redox reaction because you're adding O to make it a compound, so it's a redox. O2 is being reduced because O2 is an oxidizing agent that gets reduced. So yeah, because C is the oxidizing agent that reduces O2. This, if you took bio, you would definitely have seen this like a million times. And if you don't take bio, you'd probably also have seen this a million times. Glucose plus oxygen gives you carbon dioxide and water plus energy. This is respiration. If it was the opposite, if the arrow was, let's say, in this direction, it would be photosynthesis. Okay, so some pieces of calcium carbonate and dilute hydrochloric acid are placed in a flask. It's acid with a carbonate. We already said it produces carbon dioxide. Okay. Now, you have an alkane and Cl2. We said it is chlorination. But what is chlorination? Chlorination is when you replace one of the H's with Cl. So what are you doing to it? You're substituting it. So it's a substitution reaction. Now, here, what are you doing? You have to analyze it. So you have an alkene and you're adding hydrogen. So it's hydrogenation. It's really easy. You can tell all of these names just from looking at it. When you're adding chlorine, it's chlorination, which means you're substituting. When you're adding hydrogen, it's hydrogenation because you're adding hydrogen, which is an addition reaction, not substitution like chlorine. This question really easy. Let's do it again really quickly. It's theoretical yield. We know we have 0.5 tons, so it's 0.5 times 10 power 6. And we have 2H2, so the mass here is 4. And here we have a mass of, what's it called? Methanol is H4. 4 plus 12 is 16, 32. When we cross multiply times 32 divided by 4, we're gonna get it is 4 times 10 power 6. Times 10 power 6 means tons. So 4 tons. Now, when we want to find percentage yield, it's actual yield, which is given over theoretical times 100. Theoretical is just what we just found. So 3 tons over 4 tons is 0.75 times 100 is 75%. Now, moving on. Choose the gases that work in a hydrogen fuel cell, O2, and of course hydrogen, and it produces H2O. Memorize. We already had this question like a million times. Now, last question. Hydrocarbon, so H and C only, is 75% carbon by mass. Find its simplest formula. When you have a hydrocarbon, we know that if you only have 2 elements, this is what you do. You will do the moles of H over the moles of C. So the moles of H are gonna be, so 75 is carbon. So 100 minus 75 leaves you 25% or grams for hydrogen. So this is 25. To find the moles of hydrogen, you divide by 1, but we're going to divide by 1 because we will all know that it's 25. Now, to find for carbon, it's 75 grams over 12. You're going to get 4 over 1. So the H is going to have a subscript of 4, whereas C is going to have 1. So CH4. That's your answer. Hope you understood everything. Have a good day. Bye.